Okay, this is the Unit 12 preview for the test coming up on Tuesday and Wednesday. Objective 1 is the regular polygons. This is the area formula. It is already there and ready for you to use. A stands for the apothem, and P stands for perimeter. The apothem goes from the center of the polygon perpendicular to the base. So my apothem here is 14.4. So if I have 1/2 the apothem, 14.4, then I need the perimeter. My perimeter is going to be all of my sides added together. And since it's regular, that means it's congruent. So I have 7 sides that are 13.9. So if I go over to my calculator, I have 7 sides that are 13.9. So I have a perimeter of 97.3. That perimeter is going to go in part of my formula, 97.3. I'm going to go back to my calculator. So 1/2 times 14.4 times 97.3 gives me an, oh, I forgot my 0.3. Gives me 700.56. So my area is 700.56 units squared. Number 2, still applying the formula. Area is going to equal 1/2 my apothem. This is my apothem. That's A, so it's 5.1. Then I need my perimeter. This time I have 5 sides that are 7.5. So I'm going to go to my calculator. 5 sides times 7.5. I get 37.5. My perimeter is 37.5. That gets put into my formula, 37.5, and then I go back to my calculator. 1/2 times 5.1 times 37.5, and I get 96.625. My area is equal to 96.625, and that's units squared. Number 3 doesn't have a picture, but I can still find the area. Here's my apothem. My area is going to equal 1/2 of 14.1. Still need to find my perimeter. I have an octagon that tells me I have 8 sides that are 11.7. So going back to my calculator, 8 sides at 11.7 gives me a perimeter of 93.6. And that'll go into my formula with 93.6. And coming back to my calculator, I get 1/2 times 14.1 times 93.6. My area is 659.88 units squared. Okay, so these 3 were pretty much a straightforward application of the formula. Number 4 is a little bit different. My area is still equal to 1/2. 12 does represent my apothem. But now I need to find perimeter. Now the difference here is I don't have any side lengths like I did in these 2 examples. So, based on the fact that it is a square, and this is going from the center to the side, That means from the center to this side would also be 12, which makes my side length 24. So my perimeter is going to equal 4 sides at 24. That's going to equal 96, which means I put the perimeter down here for my formula. Going back to my calculator, I have 1/2 times 12 times 96, and I get 576 is my area. Units squared. Okay, so that takes care of objective 1. I'll be back momentarily with objective 2. Okay, objective 2 is composite figures. What we have here is we have a figure, and I need to find the area of it. So the best way to do that is to split it into 2 different rectangles. So here for rectangle 1, I have this bottom one, and here for rectangle 2, I have another shape. I can find the individual areas and add them together for the composite. So for the area of rectangle 1, that's going to be 2 times 12. So that's going to give me 24. The area of rectangle 2, well, I see one of the sides is 4, but I need to know what this one is. Well, I can find it. The entire length is 12, and these other 2 horizontal pieces are 3 and 5. So that means that the top horizontal piece will have to be the difference between them. So 12 minus 5 is 7. 7 minus 3 is 4, which leaves me with 4 centimeters here at the top. So that actually makes it a square. So it's 4 by 4, which gives me 16. Then I take the area of both of those and add them together, and I get 40 centimeters squared. That's the area. For number 6, I have a semicircle, that is a half circle, and a triangle. So I'm going to take the area of my circle. That's going to be pi r squared. That's going to give me pi times 2 squared, because my radius is used, not my diameter. And then I have half of that, so I'm going to take half. That gives me 4 pi over 2, which reduces down to 2 pi. And 2 pi, we're using 3.14, is 6.28. The area of my triangle is 1/2 base times height. That gives me 1/2 of 4 times 5, which gives me an area of 10. Then I add the 2 together. So the area of the entire figure is 16.28, and that's going to be feet squared. Okay, number 7. It depends on your perspective. I could see this as a rectangle and a semicircle. However, I also noticed that this circle here could be slid back into the empty space there. And if I do that, then that's a rectangle. So the area of my rectangle is going to be length times width, or 2 times 3, which is going to give me 6 inches squared. Number 8, I'm going to find the area of the shaded region here. So I have 2 circles. I have one circle, and it says leave in terms of pi. That means leave pi in my answer. So the area of one of my circles, I'm going to do the big one, the one on the outer edge, is going to be pi times 8 squared, and that's going to give me 64 pi. Then I'm going to take the area of my smaller circle, that's going to be the one on the inside. That's going to be pi times 5 squared, and that gives me 25 pi. Now all I have to do is subtract them. Why? Because I want the shaded region. I want the area that's colored in. So I subtract them, and I get 39 pi, and that's going to be centimeters squared for my area. Okay, hang tight next for transformations. Okay, blast from the past. We're going to have study figures 1 and 2. Which transformation of the figure is shown? If we have a rotation, that means we've turned it. If we have a reflection, that means we flip it. And if we translate it, that means we slide it. So if I'm trying to figure out, did I turn it? No, it doesn't look like I turned it. Did I flip it? Yes, it does look flipped. If I draw in my line of symmetry, then these are mirror images of each other. So it does look like I flipped it. Translate it? No, they would be in the same orientation, meaning they would be facing the same direction. So I can eliminate these two. That applies, so that means I do have a transformation, and it's going to be B. Okay, number 2, which apparent image of X when triangle WXY is translated 2 units down and 5 units to the right? Since they're only asking about point X, that's the only one I'm going to worry about. And I'm literally going to move it 1, 2 units down. Oops, I went left. 2 units down. So here I'm going to go 2 down and then 5 to the right. 1, 2, 3, 4, 5. This is the point that I get located at. This is my X prime. So my coordinate, I have to go over 6 and up 1, 2, 3, 4. Okay, so that's the new location. That's the slide. The only one that matches is D. Now, in class, I had a lot of people tell me C, so make sure you are not confusing your X and Y axes. Number 3, I believe this was supposed to read triangle ABC is apparently a translation of triangle ABC across the x-axis. Well, here's my x-axis. Here's my original figure. That means I would slide it here. That didn't happen, so I can eliminate A. Okay, clockwise turn. Okay, so that means I would turn it clockwise from 0, 0. That's a possibility. I'm going to keep that one. A reflection across the y-axis. Okay, well, if I were to reflect it across the y-axis, my B prime would be here, and it's not. It's over here. So I can eliminate C. And reflect across the x-axis, that means that figure would land over here. And I don't have a figure there, so I can eliminate D. So the only one that could possibly fit is B. It is a rotation. I am turning it. Okay, so this is the preview video for Unit 12. Remember, this is an individual test. You will be taking this test by yourself. Make sure you have your doodle notes because I will allow you to use the doodle notes on your test. Good luck.